Welcome back, everyone. So I've been asked to do this Putnam problem. I'm not optimistic, but we'll give it a shot. So this problem has to show that this random sum is non-negative. If you take away the layer, what this says is let's just let like a sub n. Actually, yeah, let's use n. The n in the problem doesn't matter. Well, let a sub k. Okay, fine. We'll use k. Well, let a sub k equals this thing. And my goal is to show that all the partial sums of this sequence are non-negative. Yeah, BID. Okay. Alright, so what the heck do I do with this? There's like nothing, there's like no footholds at all that I can see. Let me write out the first few just to get a sense of where they are. Okay, point, yeah, I feel like BID might be the right thing, but the problem is I don't actually remember the statement of BID. 0.414. I'm also counting. 828, 124. Yeah, so it goes back to 0. Okay, so what do BID sequences say? BID sequences promise me that let's see, floor of k root 2 minus 1. So BID sequences don't work with numbers this small, right? Do they? Is it this one and the other one? Yeah, I think it's like k square root 2 and well, that was a whole lot of nothing actually. Let's see. Oh no, I'm miscomputing it. K square root 2 and what's the other one? Actually, so here's what I'm going to do. I'm going to, because I want to use BID sequences, I'm going to let one of them be k times square root 2 plus 1. So this will have the same parities, but it will have a complementary sequence by BID's theorem. And BID's theorem is like 1 over alpha plus 1 over square root 2 plus 1. Okay, and I am a mathematician, which means I have no idea how to do calculations like this, but let's give it a shot. So this is square root 2 minus 1, right? And so what is the sequence? It's like alpha equals 1 over 2 minus root 2. I can't even spell. Is equal to 2 plus root 2 over 2 equals 1 plus root 2. Wait, what? No. That's not correct. I am a very capable budding mathematician. What is alpha? Can someone help? Yeah, we're definitely switching to root 2 plus 1 so that we don't get repeated junk. But for some reason I cannot find the value of x such that 1 over alpha plus whatever 2 plus square root 2 over 2 is not 1 plus square root 2. Oh, okay. Yeah, that seems to be an issue. 1 plus half root 2. Alright. Okay, so the BID's theorem says that these two sequences are complementary, meaning that every term appears only in one or not the other. Now I'm gonna delete this because this is irrelevant. We're gonna use +1 so that BID actually applies. So that is a random fact. Today I learned. These two things will be complementary. Alright, that's fine. Now the question is, why would there be more even things in the first sequence than in the second one at any given threshold? What's the relation between these two? One of them is like square root 2 times the other one, right? Yeah, so the constant here is pretty special. It's like... That being said, I wonder if it would be easier on me if I picked a bigger number or something. I don't think so. Hello. Yeah, like I'm looking at this and I'm seeing the fact that like this alpha, we'll call them alpha and beta. How about that? So we'll call like alpha is k root 2 plus 1, or root 2 plus 1. And we'll let beta equals root 2 over 2 plus 1. So we're looking specifically at the sequences floor of alpha k and floor of beta k. Yeah, I agree. It's very interesting to me that these sequences have a ratio 1 over root 2. I don't know what to do with that though. What can I do if they have ratio square root 2? It means that I'm gonna get my iPad. I have an idea. Can someone actually will anyone be annoyed if I like have a computer grind out the first several turns for me so I don't have to compute them myself? 'Cause I don't feel like computing them. Come on. Crap. My tablet. No! Work! You are technology! God damn it. I just saw the OEIS link. What does this paper say? Oh my god, this is the worst typesetting I've ever seen. I'm not okay. Where? Well, I'll look at that later. I have a feeling that it's a bit of a spoiler to look up something that's like that directly related. On the other hand, my idea is something like the following. Oh crap. Oh, come on. Where's my board? Evan Twitch Public. There you go. So, alpha line and beta line. I have a sequence, so I guess for example, the first few terms of the alpha sequence, the first floor is 2. So this is like k equals 1. And next one is, so let's say 2.4 and 7. So for example, those are the first 3. And then on the other bottom, basically the premise is that there's, okay, so the bottommost sequence is, alright, let me write the decimal approximations out. So this one is about 2.414. So this one should be about 1.707. So this will give k equals 1 here. K equals 2 is this one. K equals, so it looks like this. So far. And I want to see if I can, so these are related by a factor of root 2. So the it should amplify by root 2, whatever that means. But if I take for every even number here, like if I have a 2 here, if I have a 2 here, I can draw an arrow like this. I'm not sure what I'm getting at. So I'm trying to do something here. Sorry, no, this should go to 4. Where I'm like multiplying the thing inside the floor by a factor of square root 2. I don't know if it's gonna go anywhere. This is just an thought that I had. I feel like the same should be true. No, it doesn't require. This doesn't require even. This should work for any parity. Okay, let me write more terms out. But basically, I'm seeing this thing that these things have like a factor of root 2 in common. So I want to see if I can like join them up somehow. So let's see. 7.2, 7242, 9656, 12.07. Okay. And then on the other bottom, it's like 5, 6, 7, 8, 9. What's the next one? 14,484. So like for example, this 3 might go to like this 6. And there's a sort of zigzag that should happen like this, where I have this thing, and in each thing I'm like amplifying it by the square root of 2. What is ECMO 2018-3? Is it that the... I put that in formulas? Really? I thought I put that in process. Maybe it's a typo. Did you have any problems in mind? Search for IMO 2017-6 arithmetic geometry. 2015-5. Yeah, that sounds right to me. Here, I'll put it in the chat. With square root 2 directly? I don't see why it would help to do it with square root 2 directly, because the thing you get doesn't have the same thing. But I feel like these arrows, like, they should... Basically what happens is that the numbers should all get put into chains, and the chains are being amplified by square root 2. And I don't know. Like, part of the reason I'm doing this is I just can't see, like, what else is even reasonable to do. Like, what else are you gonna do? Like, you have the square root 2, you don't know anything about its binary digits. But here I at least can say, like, you know, I have a chain spawning from all the odd indexes on the bottom, like this one and this one. I should change this to be... yeah. And the square root 2... yeah, so the root, I feel like the root 2 scale should do something, right? Because it's saying, I don't know what it's saying. What's the relation between floor of x and floor 2x, where x is a real number? for it. 2479 are. What about 2479? No, it's 4 root 2 plus 1. It's this one. So the alpha sequence I have on the top and the beta sequence I have at the bottom. If I graduate from Modus this year, will it be okay if I stay in your server just to troll? You can stay in the server, please don't troll it. Yeah, so like, what is the relation between... So, I guess like why would I want to switch to square root 2 times n4? But this doesn't seem like it now has the advantage that I am now confused about. Now you have to keep track of like parity. And wait, actually now I'm confused. What is it? What are you proposing? 2, 4, 7, or 9 are also when the original exponent changes. Wait, no, what? 4, 7, 9. K equals 1 to K equals 2, K equals 3 to K equals 4. Well, I mean, I guess. Yeah, because, I mean, these two sequences are the same up to parity. Right? So, can we use that? What would that do? Like, the original sequence is like, all we've done is shift it down by 2k, I think, or something. Like, yeah, I agree the change points are the same, but I guess I don't see what it does for us or something. Like, it feels like it's also just a restatement of like, in some sense, like this problem is about a fixed sequence. Like this, it's about the sequence 2, 4, 7, 9, etc. And self-define. Actually, I kind of see what you're saying. Which is like the original problem is like, in the original problem, these are like the zeros, these are like the ones, and then these are like the twos or something. And you're asking about like the parity of the step size. Or not her, like the even index step sizes or something like that. Fairy things? I feel like fairy doesn't work with irrational stuff like this. Are they Euclidean? Oh. Yeah, that's the only one. Calculation has a link. Sorry, I didn't realize you wanted Euclidean. I just want to motivate myself to learn higher math. Okay. Oh man. Okay, wait. Would someone like tell me does this do anything? Like, I feel like I have this. I have these chains. I don't know what to do with these chains. Every number is in a chain. Also, in any chain, okay. So when I go from like 2x to like 2x or x to 2x, this is always equal to either like twice the floor of x or twice the floor of x plus 1. So when I follow the chain from the view of the top, this is either doubling or doubling plus 1. My hope is it's not double plus 1 too much. The same is true on the bottom. It's either double or double plus 1. Thank you, HH sub V. But depends on whether the index appears in the sequence, yeah. Why should I believe EGMO 2017-4 is true? Because there's a lot of... No, just do the problem. That one's... There's no trick to it, you just kind of construct it. Like inductor, like you can just kind of for the EGMO 2017-4, like you peel off T1 and Tn and then go. How did you find out about Barry? James Tao and Max Schindler were talking about it at MOP, like, I forget what year. So sometime between 2011 and 2012. And so I kind of sat down and worked out the entire theory, and then, what was it? How to peel T1 off. You just do it. Because what if things don't add up? Why do you care if things add up? Like you necessarily have some like universal vertices, right? Like some vertices that are like isolated / universal vertices. So you don't get to make many choices. You just kind of, I don't know, like. Okay. Anyways, where was I? Do you think there are still more worthwhile bashing techniques that haven't been discovered yet? Maybe. I'm not really sure. Euclidean geometry is kind of a weird situation. Because it's a... Given infinite computational power, you can do most problems, but... So the limits are more pragmatic than theoretical. Okay, let me actually think about this. So actually, when I follow a chain, the parity of... It feels like the parity of the next node in either line, like, doesn't super depend on... I don't know. Like, it feels like it doesn't really depend on the previous number in some sense. Like, if I'm looking... You don't care whether 4 is even, in the sense it's either 8 or 8 plus 1. No, don't generalize the induction hypothesis, just do the problem. Like, you don't need to generalize it. You just need to induct by two things out, like T1 and Tn at once. Could I work with rational instead of root 2? I feel like the problem would be completely different with the rational number. Like, I don't see why knowing how to do the rational case... First of all, it's probably not true for a lot of rational numbers. And I, like, don't... Okay, there's a hope that, yeah, these sequences don't work, for example. There's a hope that we could do something silly like, you try to approximate root to, yeah, you try to approximate it by a rational number that's close by. But I don't know about you. I don't know how to do rational approximations of square root 2. Thank you, cyanide for dinner. Follow. Is it true for every rational number? No way, right? Like, just take like 1.1 and it's just like false. For like n equals 1. One-digit product table. What is a one-digit product table? If n, for example, 1000. We need only 5 digits. Yeah, so that's what I'm saying, right? Like, you could try to say for any n, we try to take a rational approximation that's close enough that it doesn't matter for, like, a specific value of n. However, I don't know how you would say something. I guess I don't know how you would say something about the, like, that rational approximation. Like, you know, you need some property of square root 2 minus 1. One till 9 times 1 till 9 simple elementary product table. I don't see why base 10 should be relevant to this problem. If anything, I think you want to look at base 2, right? Just give a square root 2. Like, I agree if you can show like there's I agree that like these claims would be sufficient to solve the problem. I just don't see like how the claims look any easier than the original. Like all the like rational approximation claims. Like in particular, like you need to use something about the number square root 2 minus 1 or whatever, right? Like the like you need the actual constant. And I don't know what property that constant should have. Thank you, sandwiches with cheese for the follow. Right number plus ones and minus ones is a function of k. Probably not. I mean, I would be delighted if you could, but I don't see it happening. I don't know. See, that's the reason that I've been like drawing this arrows picture, because this arrows picture, when I pair it with the Beati, like does give you something. It tells you that there's some doubling thing happening. But it's not clear to me. Yeah, like this at least like uses the fact that it's like square root 2 minus 1, right? Because what you find is that when I move 2 steps in this arrow, the number doubles, and that's an integer, and so maybe something is going to happen. I don't know. But it at least uses the square root 2. Whereas like here, like there's a lot of things that are being suggested that like don't use facts of square root 2, and I'm basically convinced that if you don't use property of the square root 2, the solution will not work. I would also not be surprised if it was based on the continued fraction. That is also on the table. Is there a sense in which continued fractions of there's a sense in which continued fractions are the best approximations, right? So okay, fine. Let's look at this. What is the continued fraction approximation of 1 plus root 2? Can someone? I don't actually know what it is, but someone's gotta tell me. 2 plus 1 over. Ah, crap. Yeah, let me just use Wolfram Alpha. No, continued fractions is not a Taylor series. That's completely different. So root 2 plus 1, the continued fraction. Oh, wow, that's a very simple continued fraction. Okay, so I can get arbitrarily good approximations of square root 2. Well, I want 1 plus square root 2 because that's the one that is like b at e, wherever. So, okay, that's fine. So if I look at the continued fraction approximation, the convergents are like first approximation is 2, then it's 5 halves, and then it's like 12 fifths, I guess. Then it's like 29 twelfths. So okay, so my first question is there a closed form for like this sequence? There really ought to be. Let me just plug it into OES. There should be a closed form. 2, 5, 12, 29. Damn it. It's Pell. Right. Alright, but the point is, like, if you want to do rational approximation, fine. But these are the fractions you want to use. You want to use something about that. Okay. Second question: Does the property hold? Does the property hold for each of the fractions? Okay. Apparently it doesn't work for. No, this was actually okay. So this is always okay. 5 halves is like 2.5, 5, 7.5. Yeah, actually, I believe that these should work. There's sense in which if they didn't work, then probably some initial segment of square root 2 would fail. Because these things approach square root 2 really rapidly. Yeah, they should actually all work, just by looking at them. It sounds like they're good. Okay, fine. So people who wanted to use evenness, to use rational approximations, yeah, each one is a denominator of the previous one. I agree. So is it can I show that there is more even things here than odd things here? That actually seems plausible. It's interesting because some of them, so there's some of them have odd denominator. If you have an odd denominator, it promises you that that what it'll actually be tight with like 12 or something, or something. The Amy math jam has been going on for 4 hours. Okay, so fine. This might work. How do I do something with these fractions? This could work. This actually could work. Mm-hmm. I wonder if it's the case that no, that doesn't make sense. So the benefit of being rational is that there is a bit of symmetry, like it goes backwards in some. How fast does this grow? It grows by a factor of 2.4-ish. So this part will be a copy. The initial segment should roughly be a copy of the previous segment. Like I'm willing to bet that like for example the first 12 terms of this will match the first all 12 terms of this up to the last one. The problem is the sequence grows rapidly enough that that's not good enough. I need something to deal with the things in the middle. I think the key is we start from 0. What do you mean we start from 0? Which thing starts from 0? If we add 1 to square root 2 plus 1, then we flip all the parity. You're claiming the ones with odd denominator will work. That's, I mean, I believe that, but alright. See you 3v2. Seven-fifths? Wait, did 7/5 fail? No, I didn't. What? What do you mean 7/5 failed? Oh, the others failed, okay. Oh, 5 halves will actually fail. Oh, I see what you're saying, right? Because the next term in this sequence is 7.5. So this is like minus, plus, minus. So it's possible we're going to have to claim just the odd. Wait. No, that's actually really bad news. The odd denominator ones failed. Is it because this... Okay. Is it like one of these is an overestimate, the other is an underestimate? What game are you going to play? At the rate I'm going, I don't know if I'll get to play any games today. Yeah. We'll see. Someone figure out how to do this. Jeez. Yeah, it looks like the odd denominator... Wait. What? 239 over 169 works? Are you serious? What the freak? Okay, I don't know what's going on with these irrational numbers. Someone had an idea that if I took this sequence and increased it by... Like root 2 plus 2 is like I don't know. But I have to do something with the SQRT2, right? Like. What's wrong with T1 equals 2? No, you add multiple universal vertices. Like the first step does not mean you add a single vertex of with Tn. You add more than one. Anyways. Oh crap. Which one is 14.2? What do you mean what's wrong with a single universal vertex? Like, it won't work. You're finding that it doesn't work, so do something else. Oh yeah, that problem is really tough. Oh my god. Freaking... There. Why did I do this river too? Done right now. I mean, I'm just kind of staring at the problem right now. Like, I feel like this doubly, like, I feel like the two basic lines you have are, one is that you try to use the continued fraction of, one is you use a continued fraction of, like, SQRT2 in some way, and the other is this thing I'm drawing with the arrows where the things, like, double. Evan, is storing EGMO solutions on overleaf fine? I guess so. So I honestly, I didn't like any of anything I could find, so I actually wrote my own software to store databases, or to be my problem database. Like, I just wrote its thing in Python, and that has worked very well for me. But it also is a pain to set up. So, yeah, I don't see what is it pub? Yeah, so you can actually find it on GitHub. I'll send the link. Yeah, so this is the software, but it's like command line software. Like, if you aren't used to using a terminal, then it probably is not that useful for you. Yeah, I don't know if it'll be useful for me to keep working on this, honestly. I don't know if I'm getting anywhere. Like, I think the Beati is probably... You want even numerator and odd denominator. Oh, okay, so maybe that line is possible. Wait. Odd number. Is odd number odd denominator? I'm confused now. So is 12/5 good? Or... I'm not sure what you're suggesting. Is Beati? Well, I just grabbed the Beati because I didn't know what else to, like... I don't know. Claim all fractions even over odd less than 1 should work. Yeah, that's what I was saying. You don't have only one vertex of degree Tn. That's why I said you want multiple universal vertices. No, someone's asking me for help on a unrelated problem in the chat. Is the claim that even over odd? I find that hard to believe though. Like, just even over odd is good enough because like there are real numbers for which the statement is false. Maybe those real numbers. No, that doesn't make any sense. Like, you don't expect a statement like this to be true for a random real number alpha. So what would need to be true? Like all the... That could be possible. No, that's not possible. No, what? No, hang on, now I'm confused. Okay, you know what? Let's test this. Yeah, I would be happy if it turned out that the only thing we needed about this thing was that it's continued fraction convergence to do a good thing. If that turns out to be true, I am so happy. I don't think it'll be true, but it's worth a shot because I'm out of ideas. So, ladies and gentlemen, I present you Python. GVim tried apart. I don't know. Yeah, I agree it should be possible, and let's see if it's really true that F P Q. Okay, so we'll let n equals for k in range 0, 2 times q. So s equals 0, and then we'll look at like k times p. A is this integer, and if a is even, we'll increment s by 1, else s minus equals 1. Okay, and if if s is strictly less than 0 at any point, we fail immediately. Return false. Otherwise, return true. It's probably, let's go to 4 times q just to be safe. Python. Oh crap. Okay, so for example, we'd like to see. We're hoping that 12/5 was one of the ones that. 12 this works, but 5 halves should fail. It did not fail. Oh, that's bad. Freaking, I'm so bad at programming. Ah! I hate code. 2, 5, 7. Oh, frick. This is supposed to be one indexed, right? Yeah, that's important. 5/2. False. Okay, 12/5 is true. Okay. Wow, that is a lot of ad breaks. Okay. Wait, how long goes this? Did I miss? Alright, okay, we're going to take a... How do you guys have so much ad break time saved up? Okay, we're gonna take a very long ad break while I try to figure out the code. Shout out to... No, that wasn't just a highlight, never mind. Okay. V-Bucks inflation. Other ones are too big for it. I don't know how Manir does this. Let's do this. All right. So apparently I cannot run the other 60 seconds of ad break yet because I recently ran a commercial. So here we are. But let's get back. So this is where we were standing. We had this stupid Python script, and how often do you cut your hair? Whenever I go home and my parents force me to. I kind of want to grow out my hair and have grow length hair, but my parents keep making me cut it every time I go home. So my agenda is to go home as infrequently as possible, so I can avoid getting my hair cut. Okay, so what were we hoping? We're hoping that if I have what parodies? Like so 29 over 12 fails, but 12 over 5 will work. And their claim is that maybe in general, whenever I have an even... No. So there's something that... I do need something about the size. Is the claim that if I have a number less than 1/2 and the numerator is even, then it's true? Let's try it. So if I do like 4, 101, it's true. 4, 103 is false. Okay, so never mind. It's worth a shot. Sad. The only streamer when commercials are part of the entertainment. Yeah, this stream's kind of strange. I don't know why people request ad breaks, but they do, so okay, I won't complain. Okay, so... Yeah, so you need something about the fractions. You can't just pick like a random fraction. Like a fraction, like 5 over 103 failed when 5 over 101... Or sorry, what was it? What numbers did I pick? 4 over 101 and 4 over 103 are different results. And, the stream is much more tight-knit. Yeah, I mean, MathCounts community is not that big, in some sense. I mean, like, the set of people who can really work on Olympiad-level problems is just not a very big set. So, there's a sense in which a lot of people know each other. That's one of the nice things, I think, actually. Alright. I don't think I'm gonna... I don't... What do I do with this, doubling? Can I do something with this doubling? Like 2, 4, 9... If I arrange them in chains like this, do I get anything out of it? So, actually, I really need to use the fact that it's, like, meshed like this. Like, it's not good enough to just, Alright, I don't know, man. Alright. Yeah, I'm pretty ready to... Alright, decision. no one wants to follow the arrows idea. Nuke just found progress. Wait, did I miss something from Nuke? What did Nuke say? Square root 2k and square root 2 and their average is the sequence we want. Oh, sorry, I didn't say that. Okay, let's see what this is. What are arrows? What are useful? It's that diagram I have on the left. So, right, so square root, I agree, square root 2k and their average is the sequence. Okay, so you want to do this with root 2k and root 2 plus root 2k. That's reasonable, we can look at that. So, 1, 2... Yeah, I agree. Like, I totally agree. Like, we need to, you really use the square root 2 somewhere, and I just don't see where. So, I'm willing to take anything right now. Square root 2. So, this is the square root 2 plus 2 line, and this is the square root 2 line. So, 1.414, 2.828, 4.5656, 770. Okay, and then this is 1, and that's 2, and it's like 3. And your observation is that these guys... Oh, jeez. See, the problem is that even if you know they're the average, it's not literally the average of the numbers, is it? Oh, no, it is, because their fractional parts match. Okay, fine. So... Right, so it is literally 2, 4, 7... Fine. An easy way to commute sequence is to... Okay, so I agree. So we have some sort of partition, and... Yeah, it's like the average of them, so... Yeah, we also know that these blocks are always in chunks of 2 or 3. Yeah, okay. Okay. So... Okay, I agree actually. So that actually gives us a pretty fun recursive description. I actually like this. So like when you phrase it this way, it doesn't seem like a number theory problem as much anymore. So the procedure is we write, so number line 1, you jump across by 2, you circle this, and then you look at the next one and you go like +4, and so on. And then for this one, you go. Let me not draw the circle actually. Yeah, actually, this is a good description of the terms. This feels a lot more combinatorial. So. Yeah, so this is a way you can capture the square root 2 and get rid of the number theory. What we've done is we've used the Beati property and like used it to write a combinatorial description of the sequence. This is good. I like this a lot. So this one, for example, would be like plus 6. Go that all the way here. And then this next one would be like plus 8, and it would go like. And that way you generate the sequence. So the feels like a sieve, yeah. Okay, well now we're back in business. Now I finally got rid of the square root too. Thank you, Nuke. That helps a lot. So what can I do with this? First of all, I feel like I've seen this somewhere before. Like this kind of general process feels a little familiar, but I can't put my finger on exactly where. What is the rephrase question now? So I consider the following process with a number line. I take the smallest unused for the ith step. I take the smallest unused number and draw an arrow from that number to that number plus 2i, and then repeat. So this is step 1 is this green one. Step 2 is this red arc. Step 3 is this green arc. Step 4 is this red arc. And in this way, I generate a bunch of arcs on the circle. And you would like to show something about the parity, like the yeah, we did something like this. What was that Fibonacci? The BMO problem from Balkan? No, not Balkan, British. BMO2. Ah, crap. That was the one I never wrote up because I was worried about copyright concerns with the British MO. Ah. If you replace the gaps with 2, 4, 6, 8, 1, 2, 3, 4, then the sequences are Wythoff numbers. Okay. Okay. Hey though. The first one of evens is lane 3, minus 1 equals 2, and the first one of odds. Convergence, yeah. Alright, hang on, let me parse this. The first one of evens is lane. I see. Okay, I get it. So the claim is that when I look up here, the fact that this is lane 3 means that the first two terms are even, and then this one has... Or sorry. Starting from like... Here, yeah. So this is like 2, 2, 3, and this represents the parity thingies. Okay, so I agree if you break it into runs, then what we want is... Yeah. Oh no. The SQRT2 run skips a number. SQRT2 run skips a number. I see, so the gaps, yeah, it's this, I see. So this 2, this 2, this 3. Okay. I think I see. Do you do competitive programming? Not particularly. I can like kind of talk to computers, not really. I'm pretty bad at it. So this 3 will do something, and then this 2. So okay, so like it's, I guess it's like these 2, 2, 3, 2, and something like that. Yes, I can kind of talk to computers. You are very good at talking to computers. Okay, sure. Hello, computer. This exact Beati sequence is on the... Hey Hurdler, good to have you. We've been on this problem for a while. I was about to throw in the towel, and then someone had an idea. Okay, so we have these 2, 2, and 3, 2. This endpoint. Yeah, I like the combinatorial description. I'm trying to think if there's anything we can do with it. 10, 10, 10, 10, 11, 12. Parser. Yeah, we were looking at the continued fraction conversions earlier and couldn't figure out what to do with them. But admittedly, I was kind of like, I was hoping the claim might be true for like continued fractions with like, I don't know, like even denominator and odd denominator that were less than a half or something like that. But oh, that didn't work. Then write the sum explicitly in terms of the sequence. Okay, let's do that. So we'll go ahead and actually write AI equal AK equals floor 2 plus root 2 k now. And it's enough to prove what? We want like help. So if I write that sequence, then like this guy is A1, right? This is A1, this is A2, A3. So okay, so we want like for even integers, A1 minus 1 plus A3 minus A2 plus A5 minus A4 to be at least the... Where do I cut it off? At some even index, yeah. 2k minus 1 minus A, 2k minus 2. Minus 1, minus 1, minus 1. We want this thing to be at least A2 minus A1 minus 1 plus blah blah blah. Okay, so fine. Things happen, and this is the same as saying so I kill off all the minus ones, and it's like A1 plus A3 plus divide out the 2. Okay, so that's what it comes out to, right? Minus 2. Cool. Alright, we want this to be true. With this definition. What's the song in the background? This is Still Lying There by Approaching Nirvana. Went from Geo to combo and now to... Okay, so... You know, now that I'm finally here, I'm wondering, like... Why did we take so long to get here? Did I just not think to look at runs? I think I just didn't think to look at runs at all. Even though the problem tells me they were in groups of 2 and 3. I guess I insisted on switching to root 2 plus 1, and that was kind of like self-harm. Maybe add A0. Maybe. I mean, I could add it, I guess, if you want. But I'm not terribly sure it's helpful, honestly. Well, whatever, you can keep it around. They should die to induct. Well, actually, you might be right. What happens if it's... Is it just true if I... So if I increase k plus 1, what's the change in the equation? It's like this thing should increase by a sub 2k plus 1, and this thing will increase by a sub 2k plus a sub 2k plus 2 all over 2. Does that look plausible? Oh, sorry, no. This is, yeah, actually, you might be right. Because it feels like the right hand side has 2 things which round down. So the right hand side heuristically just should be smaller. Really? Wait, okay. Someone tell me, is it actually true in general that like... Is this a true inequality? Okay, never mind. Okay, so never mind. So this inequality is definitely not true. Yeah, that's too much to hope for. Okay, that's fine. Back up. Okay, so we're not going to look at just one change. Jensen does not work here. The floor function is not convex. Or concave? Sorry, concave. Why is it square root 2 plus 2? No, concave up is horrible. Who says that? Oh my lord, no. No. Yeah, so we switched to 2 plus root 2, whose complement is... Why did we switch to? Whose complement is square root 2. And basically what's happening is that actually, this picture, this is root 2, this is root 2 plus 2, and the averages are the ones that are... The averages are the sequence you care about. Anyways, I think the upshot of doing this is that the original sequence, what you find is the original sequence looks like the length of the runs corresponds to the picture at the bottom. So I'll do it this way. If I fill in the picture, the sequence we actually care about is root 2 minus 1, which is not in the picture right now, but what happens is the parity is like 0, 0, 1, 1, 2, 2, 2. This, I'm just writing the sequence. So because of this line here, where the yeah, the parity changes exactly when there's gaps in the root 2 sequence. So that's why we've switched to looking at the square root 2 sequence. So anyways, we've reduced to proving this inequality, which is like at least the close sum. Yeah, there's equality at the end of the 9 run. Yeah, which is not good news for us. Why is this inequality so strong? Well, yeah, I think square root 2, I think we're right, and like 2 plus root 2 or just square root 2 is the right thing. In fact, you know, actually, if I'm looking at this, the colored inequality here, it feels like we should just write like, we should take out the 2k part, right? So if I let bk just equal square root 2k, and I remove the 2's, the left hand side has like the sum from 1 through 2k minus 1, the other side has yeah, we can take out the 2 plus, I guess. And now it looks like this. I hope this is right. Yeah. So it would also be equivalent to prove it without the 2 plus root 2. That'll make things... Yeah, so this checks out. And so that's where we stand. We want to prove this inequality, and this is... what do we do here? No, you can't do it by induction. Or you can't do it by the obvious induction. Someone tried this earlier and we showed that it doesn't work. It's not true that if you increase k by 1, the delta is not negative. So I need something stronger. Yeah, the problem is there's too many there's equality cases that are later. So induction, but you use 2 basically and skip by 2 each time. Also can't work. The problem is that, like, so we have this thing, right, where we want to show this thing initially, like, k equals, let's just say k equals 1 is equality or something. I think it is. Is k equals 1 equality or k equals 0? It doesn't matter. Basically, there's a point at which k equals new computed that eventually this thing goes back to k equals 9. So no matter what you do, like, you know, even if you try to do it from k equals 7 and go like this, the delta is negative. So yeah, because of this, like, because it touches back down, there's no way you can get it by looking at just this change, because this change can be negative. Did someone put an ad break? Someone put a lot of ad breaks. Let me just remind myself there are k minus 1 terms here. EGMA 2015 problem in global. Which one is that? Yeah, actually, it would be equivalent to status for fractional parts. But sum of fractional parts of I don't like it. We still need to use root 2 somehow. Like, it's just not going to be true for random irrational numbers. Yeah, I agree. The fractional part, it would flip the sign. But, I don't know, like, what am I going to do with that? Yeah. Root 2 looks too badly behaved. Oh, yeah. Okay, so root 2 plus 1 was the one that had the really nice continued fraction, right? I'm not sure what property would I use of it though. I wonder if I could like try to use the same Python program and maybe we have a hope that if you have a rational number that's... Is that gonna work? Seems like a stretch. What's the hope? If I have a rational number that is close to... The inequality is an equality if you take away the floors. For one. Like, it's actually an equality if you take away the floors. So this is a statement about numbers rounding in certain ways. The other thing I'm thinking is that we could maybe consider trying to look at the consecutive differences of the BI, and they would give us sort of the same... I wonder whether it would be the same thing with, like... Can you get a fractal version of the problem where we transform the thing into a parity statement, and then that you transform that parity statement into we transform a parity statement into the sum statement, and you transform the sum statement back into a parity statement or something like that? That seems really far-fetched. So anyways, this is the thing I've written here is that is that. Hang on. Okay. Stir me inward. Okay. So when is B3... So if I let b equals the root 2 minus 1, then each of these terms is either 0 or 1. And also b sub 1 is equal to 0. So when is b3 minus b2 equal to... Yeah, we're still on this. I told you this is going to take forever. People really... We feel a little better. So we were able to... What we did is... we looked at this root 2 minus 1 and we noticed it comes in blocks, and the blocks are described by the similar sequences for root 2 and root 2 plus 2. So like in this picture here. In that way, we're able to transform the desired inequality into something that doesn't involve a parity sum. It's just a straight sum of things. Now what I'm trying to do is transform the sum inequality back into a parity inequality, except with a smaller index, in the hope that I can try to do some very demented induction. Because I'm now down to here. So my question is, when is b3 equals to... When is this true? When is this true? This term here sucks. At this point, I should start writing what the sequence is. So, okay, let me. I want a calculator. B7 minus B6. So this is the first few terms of the sequence are 1, 1, 0, 0, 0, 1. Does that match any? Does that match the sequence I have here? No. Maybe I grouped them the wrong way. 0, 0, 0, no. No, no, no. What sequence is this is like B3 minus B2, B5 minus B4, etc. And I'm trying to like very roughly I want to reduce the problem. I want to do an induction that's not induction by one. I want to like somehow group these terms in a way that it's like recursed on itself or something. Like this inequality we have, I want to show it's like, I don't know. Because when I write it this way, it looks like the binary sequence again. But because we've compressed it, it will allow us to do an induction. Like we can use the truth of the statement up to some small number. It's sort of like Cauchy induction, in which you show if a statement's true for n, you show it's true for 2n or something. Yeah, so it feels like it's that the problem has a copy of itself inside it. But this sequence is not the right sequence. This one's off. It's basically I'm running into trouble because I have this b2k over 2 term here that isn't behaving. I don't think that will match. So maybe that means I'm pairing things the wrong way. The problem is false for most numbers. Like there's no way it's true for most numbers. So we've already used the square root 2 minus 1 once in order to change this sequence into these two things and relate it down to here. We probably, yeah. So we've actually used the exact number already. But I agree the sequence feels like it is fractal, and I want to find the right manipulation for it. I don't see it that way. Okay, so I want to not have this term here, because this term here is causing lots of problems. I should have a plus b0 here, really. Or, actually better, no, let me just, if I do b this way, then I make this b1 over 2. And now the number of terms on both sides is the same. So the question is, how can I pair them such that it like looks like it makes sense? So what if I do B1? I think in order for this to work, I need like a second order thing, right? Like, it's like sum of bi minus 2bi plus 1 plus bi plus 2. Found a good associated sequence. The Pell word. Okay. Will that correspond to the thing we have here? I'm curious. I think I'm still writing Python too. The problem with this red thing is that this thing can be 1, 0 or -1. It seems to... Dang. X squared minus 2. Okay. If I... is there a way I can push this green line? Like, I want this green one to work. I'm not sure I can force it to. Okay. I think I better write this as like -1 to the I plus 1 times b sub I minus b sub I plus 1. And this thing will be the same sequence. Yeah. Okay, so I think that's how I want to write it. And this is now weird because this thing is either in 0 or 1. And this sequence is, the first terms of the sequence are 0, 1, 0, 1. Wait, so this is the same sequence, right? This is the sequence we were looking at earlier. So it's written a little differently now because instead of -1 and +1, we have like 0 and 1. But it's twisted with this, it's like, this thing is strange. So is this the same thing? Are these equivalent? Like, I feel like this is, I want to say this is exactly the same, but I'm not 100% sure. Yeah, this is the same word that Andrew found, except with, wait, let me check. 1, 1, 2, 2, 3, 3, 3. It might not be this quite the same one actually. I'm just confused at this point. I'm confused why this minus 1 to the I plus 1 showed up during this calculation. Actually, so I think this is 2, 2, 3, 2, 3, 2. I think it's the same word. Why is B1? Well, B1 equals 0. Yeah, I wanted to normalize them so that some of the coefficients on both sides are the same. So when I did the adjustment, I forced it such that B sub 1 was equal to 0. So this is the sequence bi minus bi plus 1 minus bi. Whereas the original thing we're looking at, wow, okay, there's so many related sequences with different conventions that I'm having a hard time keeping track of them. Sum of index times coefficient equal. Well, I'm doing this, so. Yeah. So, this sequence that we have here is, I don't know what I call this. Well, we'll call this root 2 minus 1. Okay, let me verify to myself that this does what I want. Oh, my Apple Pencil's running out of battery again. This always happens. Print K and zero, zero. green 0 0 1 1 2 2 2. Yeah, so I think I'm pretty sure these are like the same sequence in some sense. Like what happens is in the BI sequence, I think the super long one was more like 3 hours. It wasn't quite 5. But basically, so let's recap. And this is the thing. I think Eknarwala has given us actually the exact word as well, and it's starting to come together. So we have the sequence 0 0 1 1 2 2 2. These parodies. We found that the places where it changed sign corresponded to the sequence of like root 2's here. So like this root 2 sequence. Consequently, the original inequality boils down to this statement for like a sub k equals 2 plus root 2k, because by Beatty's theorem, the gaps are here. Then we subtracted 3, and we got this green thing, and this green thing rearranges like this. So it's similar, except now there's a -1 twist here. And this is like a sequence that's either 0 or 1. And what we found is that this BI sequence, if this is true, I assume it's like not very hard to prove. Also, why is the sign flipped? No, the sign's fine. For I equals 1. Hang on. Did I flip the sign? I flipped the sign, didn't I? Yeah, it should be BI plus 1 minus BI. Oops. Now we see that this red sequence, well, our claim is that this red sequence lines up with the green sequence. Wait, my sign is right? No, you want like... Hang on, what did I do? Okay. B sub 1 should be... Oh, okay, I see what I did. Let's just flip them twice. It's very annoying if the yeah, I want this to be in 0 1, and this should be -1 to the I. That's fine. Yeah, so it's the red thing now turns out to be the same as the green sequence, I think, where it's 1 at the places where the green sequence changes. So when this changes mod 2 is exactly when this thing yeah, that should be pretty clear. So what's happening is like when I look at blocks, then whatever. Okay, so now I would like to bring this back into here somehow. So what's going on? So this is no change plus... The problem is this -1 to the I is confusing the heck out of me. But I would like to use reduce this to this being... So if these partial sums are all non-negative, I think so, yeah. So in the B minus B sequence, the runs are correspond to here. The runs always have length 2 or 3, so yeah. I wonder if I just pair them into blocks or something. Let's make this a block. So this is like plus 0 minus, minus, or something. And this is like plus. And this is plus, plus, minus, minus. So if I throw out the zeros, plus. Yeah, I think it's the same sequence. Because the zeros, it's always 01 or 00 and then 1010. I think this is a complete fractaling. If we've got it, I think this will work in some duration. I don't know how this happened, honestly, but I think this is like this purple. I think these purple things like plus plus and 0 minus. It should be that, right? I think. I'm a little confused as well right now because. No, hang on. I'm stupid. I claimed the second collapsing somehow, and I didn't justify it. I'm somehow pulling them back in, like the. I agree we're very close. I think we're almost there. Let me think this through a little bit. Maybe my purple signs on the bottom are wrong. I think I'm trying to redo the problem twice, and I only need to redo the problem once. What do I want to claim? I want to claim that at the end of each red block, the total delta is equal to twice the total delta on the bottom, or half. Sorry, yeah. So here's the claim, I think. I'm gonna write these numbers in blue. Yeah. Ah, crap. The purple, for some reason the purple doesn't erase. Frick. Right, so in blue, let me write so this is +1, +2, +2, -1, 0, +1, for example, on the top. On the bottom, this is 1, 2, 1, 0, 1, What the heck? No, 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 no. No, 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 no. What the frick is going on? No, so it does have, I think. Okay. It goes from 2 to 1, not 0 to 1. Wait, what? 1, 2, 2, 1, 0, 1. Okay. And then this is like 1, 2, 1, 0. Right? It goes from 2 to 1. Not 2 to minus 1. I'm just a little confused. So 1, 2, 3, 2, 1, 2, 3, 4. I need to group the 3 block as 3. Oh, that makes sense. Yeah, actually, that makes a lot of sense. Yeah, I mean, so this is the thing Eknerwala was pointing out earlier. It's like, it should do this. But I feel like, how do you prove this, though? Along a run of 2 blocks. There are on each side. Apparently the 3's determine how long a run of 2 blocks there are on each side. It's still in the same sequence. How do I show it? Two with a 2, 3. Yeah, it's so the sequence that Eknerwala sent is this one. It's like, and I think this, well, the thing we have is basically a variant of this. So yeah, either that or exactly the same, depending on how you normalize it. The thing I'm trying to figure out is like, how do I explicitly get the... Like, I feel like I'm in a situation where I know the things are true. Like, I know that the sequences are quote-unquote the same for whatever quote-unquote same means. But I'm not able to... Like, I want to explicitly get, like, the BI statement. I want the green thing to tell me something about the red thing. Like, the bottom... I want the fact that this thing is non-negative to tell me something about the thing above it being non-negative. And I don't see how to force a second connection. Or something. But I feel like I should just be able to do it or something. I don't see where I'm stumbling. What am I missing? So let's just group it into chunks. I think it should be true that the end of each block is non-negative. Like this 0 corresponds to like this thing here. Like it's like plus plus minus minus. But I was hoping that this thing would like line up in a more one-to-one way. Because otherwise I don't... Yeah, join the struggle bus. It's definitely the same sequence. But, like, if I can prove this, then I probably could have solved the original problem using it, I think, or something like that. So... So what am I missing? What exactly? What do we want? I want to prove the red inequality is the TLDR, and I can use the green inequality for granted by induction hypothesis. Or not the green. The green. I can basically I want to like use the green thing to prove the red thing. Like the fact that the green, this green thing goes like up up, down down, then up 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 up, down down, and I want to use this to like say something about the red sequence, and I am really struggling. Strings of length 3 happen on integers of the form. The strings of length 3 happen on integers of the form 4 root 2 plus 1 I. I see. Okay. The lengths of the strings follow the same. Do you mean like root 2 plus 2? Not root 2 plus 1? No. Wait, what? Subtracting I. Or I guess I'm a little confused because like the first few integers of the form 4 root 2 plus 1 times I are like 3 and 6. But these flips happen at like not this one happens at index 5, this one happens at index 3. I guess I'm not totally sure what you're subtracting from what. Oh. Okay. I see. You're not talking about the index. You're talking about. Oh, okay, got it. So this is the. This is with the move down bi. Fine. Do I think I can write this up? I feel like this write-up is going to be so confusing because it's like doing the same thing in. Oh, this is going to be a fun write-up. All right. All right, let's give it a shot. It sounds like we have all the ingredients. I am still kind of confused, but we'll work it out. So it turns out we didn't use continued fractions. I'm glad we got it though. I didn't think it was going to end. Okay. Let's find out if we have everything. Yeah, I was about to, I was like, this is not working out. Alright, so for concreteness, we illustrate several terms. I think I'm going to have to look at this table so many times. I may have leaked one of my, oh no. Oh, you shouldn't have said that. Okay, so the sequences we're looking at are like root 2 plus 2, root 2 itself, and then root 2 minus 1. BID to advanced. That's fair. One, two, three, 4, 5, 6. 1, 2, 3, 4, 10. What did we agree the first few turns of the sequence were? Is this a little... Putnam problem difficulty varies quite a bit. I will say this feels like... I feel like this is on the hard end for a B6. I would not say this is like the hardest B6. Okay, 14... Okay, so we'll go up to 13. I think that's... Oh crap. Actually, this is really hard to typeset. 17. Okay, that should be enough terms. And then on the bottom, we will write square root n minus 1, 0, 0, 1, 1, 2, 2, 2, 3, 3, 4, 4, 4. So these are the these are the different pictures we're going to be playing with throughout the problem. And I have a compiler, great. Extra alignment tab. Have more. Now let me cut out 18. Okay, so claim, so by BID's theorem. Okay, well you can watch the write-up while so I'll be honest, I'm not sure we have a solution. I think we do, but I am confused as heck. So the sequence is root 2n and root 2 are disjoint and form a partition of the positive integers. On the other hand, in the bottom sequence, the consecutive runs should all have length either 2 or 3. So, well, let's give these sequences names. AN equals this, BN equals this, CN oh frick! I did fractional parts. No. Oh, this is annoying. Record macro. See change left L floor, right R floor, Q and A. I love him. Oh frick! It's left L floor, not R floor. That looks terrible. Showing the first 17 terms. Grouping into those blocks in the bottom, it is enough to show that, so we want the sum of okay, so when we do the block statement, it's like A1 minus so we want A1 minus A0 plus A3 minus A2 minus 1 plus blah blah blah, and we want up to A2k minus 1 minus A2k minus 2 minus 1. We want this to be greater than or equal to A2 minus A1 minus 1 plus A4 minus A3 minus 1 plus so on, plus A2k minus A2k minus 1 minus 1. That should be displayed actually in 2 lines. It's too long to fit on a single line. Okay, so do we agree we wanted to use I called it B in the thing, but so using the fact that AK equals 2k plus CK and then rearranging appropriately. Oh, I'll just say we can replace every AK with CK above. Then rearranging gives the desired is equivalent to the sum from I equals 1 to 2k minus 1 of so this is 0 or 1. Okay, fine. Okay, and so we're kind of looking at the CI plus 1 minus CI. Thank you, 579 for the follow. So I have to write another row here for CN plus 1 minus CN. So it's like 0, 1, 0, 1, 0, 0, 1, 0, 1. Sorry, I missed the in-between. When you're done, can you briefly explain what's being done? So the problem statement is, I mean, it's up here, it's this thingy. So it's the Putnam B6. And very roughly, our solution revolves around making like this very large table and crossing our fingers. I am not totally sure what's going on myself, but I will post it when I'm done if it indeed turns out to work. I think it should work. Okay, so now we need to prove the that this thing is shoot, I forgot the -1 to the I. Yeah, so when I draw the table like this, it's a little more clear what's going on. What am I trying to push? What are we supposed to do after this? we have like this thing. How did we show as fractal? I want this the indexing of the runs corresponds to the original sequence. 1. So in the notation that's written here, what's the correspondence I want? Okay, a-nth block. It's not a-nth though, right? Like, because this appears as a 3rd block and this appears as a 5th block, right? Did we make a mistake? Root 2 plus 1. Okay. But then that's like second and fifth, or no, not second and fifth, second and fourth, and first. Yeah, second and fourth. This matches. Oh, are you counting this as second and this as fourth? Okay, that's fair. So okay, so the claim is that let's see. Consider the blocks of correspond. The blocks of lane 3 course is exactly corresponding to the elements of the set. Okay, so I have to add like yet another one. Do I ever use root 2 and I feel like I don't. Whatever. No, I kind of do. I use it for the BID. Okay, and the proof is just to look at consider AI minus I and BI minus I. Two, 4, 7. Yeah. So what do I do with these two sequences? I'm a little lost. So if I subtract I from each of these, this is like, I get this thing. And then there's a sequence. So these two are complementary. And okay. Like yeah, so I agree. Root 2 plus 1. Which sequence is A and D and complementary to? It's like... Thank you, Lucario61 for the follow. This 4 is that 4 apparently. Why? Yeah, I guess I just don't see which sequence is complement to DN. Okay, so I'm not just missing something. Well, I agree, it's true. Crap. That was important. I needed that though. No. Hmm. We're a little confused. Like I think we have the right picture, but I can't see how the details work out. Hmm. Okay, I'm gonna comment out this row because I don't think this row really fits in the picture. Walking through BN, an adjacent pair means there will be a 2 later down. The line in the gap means there are 3 down the line. I mean, all these things are true. I just can't prove them. Not hard, it's just Biati. Okay, what's the Biati counterpart for root 2 plus 1? It's like... root 2 over 2? That doesn't make sense. Yeah, 1 plus root 2 all over 2. I think we don't really want to play with that. God, yeah. What a day. If one is in... Okay, if one is in Vn and 2 is in Vn, then 1 plus 2 and 2 plus 4... Wait, really? Like 9 is not in... Wait, 1 plus 2 is not in AN. 2 is in... Wait, what? 1 is in BN and 2 is in BN. 1 plus 2... Or, no. 1 plus 2 equals 3. Right, but if I do... Like, if I look at 4 and 5, right? Like, 4 and 5 are here. That sum is 9. Am I not understanding correctly? Four and 5 correspond to 10 and 13. Now I'm really confused. What are we... Okay. If one isn't BNT... Hi, finally I find a mathematician. I don't know if I qualify as a mathematician, but hello, welcome to the stream. Okay, wait. No, why is that here? The heck? Do you know abstract algebra, bro? I guess, kind of. B sub n plus 2 sub n. Okay, I see what you're trying to get at. So you're saying that from this thing, can we do one later? Oh, do you have an abstract algebra problem or something? Yeah. You can just post it in the chat, and if I can quickly see how to do it, I'll say so. Or possibly someone else will grab it. Okay, but okay, I see what you're trying to do. So if Bn is here, right, plus 2, okay. Okay, so if I have a length of run 2, then it will generate a run 2 thing later. Got it. Okay. Okay, so scrap claim. So the claim is that oh, this is tricky. Yeah, basically, if I know something, I can read some term in the future. I don't know how exactly what future term that is. Freaking. Okay, so, right, so for each term, consider, so 7, if there's a 7, 8, 9, then that will give me, which one is 7, 8, 9? This is a B5, so it's like the 17, and then the, 17, 20, yeah, 2, 2, 3. Okay, so you are correct. This will correctly give the fractal thing. So how do I formalize this? 2, 2, 3. So claim the, I'm not sure what the claim is actually, but I'll try to write the proof first. So imagine reading bi from left to right. If bi plus 1, bi plus 2 are adjacent, i.e. So bi plus 1 okay, so then ai plus 1 is equal to ai plus 2 plus, hang on, yeah, plus 2. ai plus 2 equals ai plus 1 plus 2. Sorry, this is plus 3. So this will give 2 blocks. So this will, in the future, ahead, this gives 2 blocks of length 2. In the future. So for NSA Hacker, I'm a little confused now, because you sent me a wiki on abstract algebra, which is fine, so I'm looking through this and it explains what abstract algebra is. And then you gave me a question about 2 linear equations, which like doesn't have anything to do with the wiki page you sent. So, yeah, I'm not sure exactly what the question is. If the question is just how do you do this, how do you do the first brilliant question, add twice the second equation to the first one. Are adjacent. If bi plus 1 minus bi equals 2. Okay, so that'll do fine. So that means the adjacency is here, whether it's adjacent or not. will predict whether what the blocks look like in the future. So the upshot is that the size of the blocks corresponds to the something. What does it correspond to? If I chunk these as 2, 2, 3, 2, 3, then unable to. Yo, sorry. Yeah. This is a little Yeah. I'm trying to figure out exactly how I want to formulate the claim. I think the claim I want to say is so 2, 2, 3, 2, 3 I want to correspond to how do I phrase the fractalness? So what we're pointing out is that if I have, for example, 4 and 5 here, then it will give a block of to something later on. It's like 2, 3, 2, 3, 2, 2. What was the claim we're trying to make? So this is plus, plus, this is this. Like, I want this block to be this digit. Just plus, plus, minus, minus. Okay, I got it. If we read Cn from left to right, the indices for which Cn changes value correspond to the blocks, the consecutive length 3 in Ci plus 1 n plus 1 minus Cn. More explicitly, the ith. So the ith block of Ci plus 1 minus Ci has length 3 if and only if Ci does not equal Ci minus 1. Since I'm a mathematician, I want to go ahead and try to do a 1 index here, I think. This is C1, so first, second, yeah, Ci plus 1. Thank you, NSI Hacker, for the follow. I hope that my brilliant help was helpful. If and only if Ci plus 1 does not equal Ci. Yeah, this is C2, this is C3. Well, I really should give this a different name. Let's call this DN. This is a different sequence. Yeah, okay, and this is, yeah. All right, cool. Wait, I think this is now a proof of the recursion thingy, and now, in fact, I claim this is true for any positive integer k. So in fact, I claim that this thing is true for any integer L. Yeah, we found a very difficult way to describe the thing that was happening. So now that we have this claim, I believe we should be okay. Okay, okay, wait, so if the -1 to the di is yeah, exactly. So I under soldier combo algorithm, I guess. Like basically what happens is like when you look at the 7, 8, for example, this thing gives, oh geez, they're really big. 6. Hang on. I'm never gonna get this indexing right. Let's say 4 and 5. These numbers are smaller. Like this is 10 and this 13. So the fact that these are adjacent means that later on you have a gap of length 2. Yeah. Okay, cool. So now we should be able to finish it off because hence if we take the first m blocks of di, each individual block sums so each individual block sums to ±1 because only the last bit is 1. Moreover, the sign is +1 if and first so we change from n to k to l. What's next? M. The sign of the ith block is +1 if and only if ci equals ci is even. Yeah. Right, because this is because the 2 2 3 2 3, yeah, okay, great. Thus, because we have reduced, thus through the long convoluted chain of reductions n to k to l to m, we have found a smaller version of the original. Have the same inequality with a smaller input value. Since the inequality is clearly true for n equals 1, for a base case n equals 1, the proof is completed since n greater than 2k greater than l. Damn. I'm not being very careful at this point. The proof by strong induction. Alright! 29 minus 4 for base cases and less than let's just say and less than 10 to be safe. I don't care enough to work out what the split. We did it! And it's now too late at night to play video games. God. Yeah, I agree. Oh my lord. What a problem. Oh man. So glad I found this channel. Great content. Thanks, glad you enjoyed it. I think this channel is funny because like I have no idea what I'm doing, as you can tell. Like we solve the problems live. So it's not like other streams. Like I think there's a lot of YouTube channels where you see the person just kind of presents solutions. The solutions are really clean and they do a good job of explaining it. And this is exactly what doesn't happen on this stream. It's like, instead it's me like, you know, crashing into walls repeatedly. And we do it live! Oh my god. I kind of want to try 2006 because it looks easy, actually. I was thinking a little bit about it during the break. And I think I know, like, basically what I'm supposed to do, but I'm afraid it might take too long if I try to do it now. Oh lord, what a problem. Fractal root 2. I'm actually glad I didn't think I was gonna get it. Like, I was just like, I have no footholds, and then it ended up being the Biati and the observation that we could put things into blocks that started things off, because I don't think I would have gotten that far without that. So thanks, Duke. Can you also share the final paper? Yeah, so I'm gonna, actually I can just post now. Give me a moment to save everything to the database. What do I call this? Rigid? Parity? I'm trying to decide what I want to tag it in the database. Okay, whatever. Alright, so now we're gonna do the very... freaking... I always type that URL and then realize that that's not the correct URL. Putnam 2020 B6. Okay. Ta-da! Yeah, so I guess I'm just doing this now. But also, just for the record, if you look on... Oh my god. No! Wait, what? It compiles on... Oh my god. No! What's the error? Oh, I commented out a line, that's why. I need to be better about the new lines. Yeah, it took the entire time limit of the Putnam. But anyways, if you look on videos.html, so you go on my website and look under YouTube plus Twitch, I actually put up all the write-ups that I do onto a page here. I update this like maybe once a month. So it will eventually go up here as well. But you can find like all of them. It's like, not all of them. There's some that I don't write up because I'm too lazy to. But it goes back quite a, yeah, there's a lot. Many write-ups. Jesus. Okay, that concludes this wonderful B6. Thank you all for tuning in. And